The name Exedy needs no introduction to anyone in the modified performance car scene. As a supplier of OEM clutches and transmission parts for major manufacturers, Exedy has the technology, testing facilities, and trusted quality to produce some of the best performance clutches on the market. And there is no better proving ground than motorsports. And Exedy is a big supporter of rallying, time attack, drag racing, and drifting around the globe. The Exedy Racing Clutch range offers something for every type of motorsport and every level of modification, from lightly tuned daily driver to a 1,000 horsepower drag car. The first in the Racing Clutch range is the Stage 1 and Stage 2. They both use an OEM style pressure plate with increased clamping force combined with a full face performance organic clutch plate or 3-puck Cerametallic clutch plate.
Normally for the Stage 1 I like to use it for a mildly upgraded street vehicle. Somebody that's looking for very smooth engagement, but they need an increase in torque holding capacity over the OEM. The Stage 2, basically it's going to be a little bit more aggressive than the Stage 1, but it's still going to offer smooth drivability, but when you need it to clamp down and go, it's going to be able to do that. The Stage 1 and Stage 2 kits were designed to work with the OEM flywheel, but if you're looking for a little bit more performance out of your install, we also offer a lightweight forged chromoly flywheel, and this is a direct replacement to the OEM. And in fact, you could use it with the OEM clutch if needed, but we're really designed for the performance applications.
The next step is into the Hyper range of racing clutches, starting with the Hyper Single.
So what we have is the Hyper Single, which uses a forged aluminum cover assembly versus a stamped steel, so it reduces the weight of the pressure plate by about 50%. We use a 6-puck disc, sprung hub center, but it's also a thinner disc, so it has slightly less inertia than the Stage 1, Stage 2 disc. And then it uses the same type of one-piece forged chromoly flywheel. The Hyper Single can handle roughly the same amount of power as the Stage 1, Stage 2, depending on application. The big advantage of the Hyper Single is the weight. The total weight of a Hyper Single unit with flywheel is going to be roughly 25 to 35% lighter than a Stage 1, Stage 2 kit with a one-piece forged chromoly flywheel.
The Hyper Multi is next and comes in twin disc, triple disc with both sprung and unsprung configurations.
The main reason why you'd want to switch from a Hyper Single to a Hyper Multi-plate is you want to increase torque holding capacity without sacrificing drivability. The twin plate is still going to have sprung hub center, so it's going to absorb those harmonic noises and dampen the drivetrain harmonics, as well as allow for smooth engagement off the line, as well as it's not going to incorporate any more clamp load than the Hyper Single is. And the main reason why you're getting the increase in torque holding capacity is due to the fact that you're doubling the friction surface area over the Hyper Single. The sprung hub we'd use mainly for a high horsepower street car, one that's making the excess of 500 wheel horsepower. For someone who wants very high power street car with still maintaining good drivability, the twin plate is perfect. Someone who wants to go a little bit beyond that and make upwards of 1,000 horsepower, get into the triple plate solid hub. But the big disadvantage of that is you go to a solid hub center, so it's not going to be able to absorb those harmonic noises that are given off by the drivetrain, as well as it's going to be a little bit harsher engagement right off the start.
The flagship in the range is the Hyper Carbon series. Available in single, twin or triple disc configuration, this lightweight carbon-on-steel clutch is the ultimate in performance.
The main reason why you'd want to switch over to a carbon unit would be to strictly reduce your mass of your total clutch. The carbon material is 90% lighter than a Cerametallic disc, so it's going to allow for much quicker upshifting and downshifting. Big misconception of the carbon clutch versus Cerametallic is they're going to be able to increase power holding capacity by going to a carbon, when the truth of the matter is when a carbon disc is hot and a Cerametallic disc is at its normal state, the friction coefficient is roughly the same. The downfall to a carbon clutch is that when the carbon is cold, the friction coefficient is very low compared to a Cerametallic, so it's a very inconsistent clutch for a street type car. But for an all-out race team that's looking for the best of everything and lightweight, good torque holding capacity, and good drivability, carbon clutch is by far superior over a Cerametallic.
To choose the right Exidy racing clutch for you and check your vehicle listing, head to the website. There is also comprehensive technical information and installation instructions.
Excellent and dynamic. Exidy. As a drivetrain specialist, Exidy is dedicated to the pursuit of quality and performance, as well as easy and reliable operation. The clutch is a mechanism that smoothly transmits and cuts off engine power to the transmission by engaging and disengaging. The clutch cover and flywheel always revolve together with the engine. When the clutch cover pushes the clutch disc against the flywheel, engine torque is transmitted to the transmission. When the driver steps on the clutch pedal, it releases the pressure plate that was pressing the clutch disc against the flywheel, disengaging the clutch disc. In this state, engine torque is not transmitted to the transmission. The clearance between the clutch disc and pressure plate when disengaged is approximately 1 millimeter for passenger cars and light commercial vehicles, and 1.5 millimeter for medium and heavy commercial vehicles. This engagement and disengagement is the basic principle of a manual clutch. The clutch cover's diaphragm spring is a disc-shaped spring that presses against the pressure plate and controls the amount of pressure applied. The amount of force that presses on the diaphragm spring is called the compression force. The graph that shows this change in compression force is known as the clamping load characteristic. This indicates the clutch disc's usable range. If wear exceeds this range, it will be impossible to obtain the necessary compression force and the clutch will slip. The release load of the diaphragm spring and pressure plate travel when the clutch disc is disengaged is shown by this graph, which is called the release characteristic. The other parts that comprise the clutch cover assembly are wire rings that serve as the fulcrums for operation of the diaphragm spring, strap plates that secure the pressure plate, and the clutch cover itself, which contains all of these parts. Next, looking at the clutch disc assembly, engine torque is first transmitted from the pressure plate to the facing material. This facing material is supported by the cushioning plate, which makes half-engaged clutch control possible. Engine torque is transmitted to the retaining plate and clutch plate, which hold the entire assembly together while actuating the torsion springs. The primary function of the torsion springs is to absorb fluctuations in engine revolution. Finally, engine torque is transmitted to the transmission via the splined hub. Fluctuations in engine revolution while idling are absorbed by this two-piece splined hub, which is coupled with several small dampening springs. It functions to prevent a chattering noise when fluctuations are transmitted to the transmission. The shock from engaging the clutch while accelerating is absorbed by torsion springs like this one. The cone springs, friction washers, and friction plate function to quickly stop the torsion springs from vibrating, reducing both noise and vibration. During engine braking, the torsion springs are compressed in the opposite direction compared to when accelerating to absorb the shock of deceleration. When driving at a constant speed, fluctuations in engine revolution are absorbed by the torsion springs and friction washers. This reduces the amount of chattering noise transmitted to the transmission and the differential gear. Due to its inherent design, an automobile engine is normally subject to revolutional fluctuations. Such fluctuations are caused by explosive combustion of the fuel and by imbalances in the crankshaft and other inertial components. Fluctuation in engine revolution is one of the main causes of noise and vibration problems in the drivetrain. Now let's take a look at the mechanism by which noise is generated due to fluctuations in engine speed. Even while driving, except for the drive gear, the other gears spin freely on the shaft. The rattling noise commonly heard is generated by these free spinning gears. As you can see, fluctuations in engine rotation speed cause the teeth of this pair of gears to strike each other. This is what causes the rattling noise. This rattling noise is not only heard directly by the driver, it is also transmitted through the shift lever and other structures. To prevent such noise, the fluctuation in engine speed is absorbed by a clutch damper function. which suppresses movement of the free spinning gears and attenuates the vibration transmitted to the transmission. Now let's take a look at the clutch damper function using a conceptual diagram. The clutch damper function is provided by a spring located between the flywheel and the transmission. If the spring used for the clutch is not appropriate, at certain engine speeds, the vibration in the transmission and the differential gear will be amplified. This will aggravate the noise of gear rattling and transmit more vibration to the vehicle body. By using a spring with the appropriate rigidity for the clutch damper, the vibration produced by the engine is prevented from being transmitted to the transmission. This is how the clutch damper function works. As a drivetrain damper specialist, Exidy employs the latest noise and vibration analysis technology to develop clutch dampers that ensure quiet and comfortable driving. The advanced noise and vibration analysis technology offered by Exidy's NV Tuning service enables us to provide products and support that promptly and accurately respond to specific customer needs. By utilizing vibration analysis technology to perform measurements and tests on an actual vehicle for a highly precise evaluation, Exidy has created an environment that enables rapid on-site development of the ideal clutch damper for each customer vehicle. One example is the NV Tuning service vehicle, which performs on-vehicle tests at a customer's test track in order to provide the ideal clutch damper with a significantly shorter lead time. The customer can see the results right there on the spot. The Exidy NV Tuning service enables on-vehicle tests of a variety of products as they are being developed, allowing Exidy to provide products of superior quality in a much shorter time. Exidy's leading-edge noise and vibration analysis technology is embodied in every Exidy product. Exidy's wide-angle damper employs the first mechanism in the world that can absorb fluctuations in rotational speed while idling, as well as vibration and shock while driving. Employing a unique viscous damping mechanism, Exidy's HydroDamp system ensures an exceptionally quiet and comfortable ride, even for diesel-powered vehicles such as large RVs. For vehicles with automatic transmissions, Exidy torque converters with a damper-equipped lockup clutch ensure greater riding comfort and lower fuel consumption. The Exidy wide-angle damper for commercial vehicles provides trucks and buses with superior quietness and comfort. Exidy is dedicated to the development of the best drivetrain dampers in the world. By emphasizing quietness and comfort, fuel economy, and other environmental concerns based on a thorough understanding of customer needs, Exidy will continue to develop impressive products that both surprise and delight our customers.